So let's talk about what you're going to be handing in and what the deliverables are, okay? So Module 6, practice problems, I'm going to click on that. And you're going to notice I kind of expanded things out from the last time we were together. So to kind of give you details of what we're looking for here. I thought the easiest way to hand in was to have one file to hand in. So you're going to be handing in your Excel spreadsheet file. Okay, so I want the actual Excel file, however it comes out, but the actual file, not a screenshot. Okay, there's going to be way too many screenshots to do that, and it's like yuck. So just send me the file. Now, inside of that file, you're going to add a summaries tab. Actually, the summary of results is there already. It's like that sheet 3. And you are going to do the following. You're going to list what your minimum shaft diameters were. Okay, so if you do end up comparing a left and a right, you want to tell me what that minimum was. And you're going to create a little table for that for me. Okay, then you're going to do a little table for the actuals. Now, what does that look like? You can do something just like what they did on the top of page 529. Okay, top of page 529, they made something like this. And in Excel, it's a natural place to create a table very similar to this. Make sense? Okay. And you can just call out, instead of calling out the names, you can say A, B, C, D, E. That's all I need to know. Okay. Then let me go back over here. Then you're going to take screenshots of your proposed shaft diameter. Now, for this one, you don't need to worry about it for the practice problems because it was given to us in the actual problem, okay? But for your homework problems, I will need a proposal of how you plan on putting these together, because they're just going to give you center lines and where the elements are. They're not going to have shoulders or keys or any of those elements in there, okay? So I want you to have a nice sketch of that. Then for the practice problems, you need sketches of your shaft forces and bearing reactions. So that's going to be your free body diagram that you created for me, the right side, front, and the top view. Screenshot or a picture, okay? Then what you're going to do is you are going to have your shear and moment diagrams, screenshots, because again, these are all screenshots, okay? And then a screenshot of your torque diagram, conditions diagram. And then I'd like you to make a rough sketch. Doesn't have to be perfect, but use a straight edge of what the drawing of your shaft is going to look like using just these basic nominal values of your actual diameters that you've bumped up to like basic sizes. So as we know, when we get our minimum shaft diameters, they're going to be funny numbers. We want to bump those up to the next basic value. For instance, if it's inch values, you want to go to the next like fractional, inch that makes sense. And then you also wanted to take into consideration assembly like we talked about last time. Okay. So making sure that those are there, and just make me a sketch. It doesn't have to be toleranced, doesn't have to be perfectly dimensioned, but now just kind of, show me pictorially a graphic of what those diameters mean to you. Okay. Yes.
So we can use CAD.
You absolutely can use CAD. If you feel more comfortable and you want to do a CAD drawing, just make sure that then you have to kind of mess around with dimensioning and making sure that you can see the dimensions when you print it out, that kind of thing. But if you want to do it in CAD, go for it. Absolutely. Or if you want to do it in Creo or in AutoCAD, whatever you want. Yeah. Or sketch it. You can hand sketch it by just using a straight edge. Okay. So it says here, all hand sketches must use a straight edge and neat handwriting. I'm going to remind you guys, you are in your final term before graduating, okay? Or a semester, I should say, not final term. You got one more term to go technically, but you're getting ready to be out in industry, right? So making sure that we're submitting things that are of a level that are more professional, okay? We're not just chicken scratching, okay? And then lastly, I have a couple questions for you, kind of those standard things. I really like this. This is something that's new, as I've told you before. And in the comments, I'll always respond to you individually, or I might even bring it up. And sometimes I've done some things in class to review some things that especially if something comes up more than once. Okay. So, so continue to answer those questions for me. Now, when we look back at our Excel spreadsheet, let's look at that summary of results sheet. And this is where you would create your little tables for your actuals and your finals. I'm sorry, your minimums and your actuals. You get the freedom of how to do that. Okay, so I'm just asking, I want to know what all your minimum shaft diameters were. I want to know what your actuals end up being. Okay, so you can devise a table to do that. Then what you're going to do is screenshots of, your proposed shaft design. So then you can just like cut and paste those pictures or those screenshots right in here. Okay, and I thought that way, now when you save this, now you've got just a file where it's all in there. You don't have all these separate things to upload. Does that make sense to everybody? Okay. So that's how I'd like to hand it in. Now, if you have difficulties doing these things, just reach out to me. I don't want this to be a big headache or a big frustration. I'm trying to make it easier. So if you're like, it's easier for me to do, this separately, that's okay. That's okay. But I'm just saying, if you want to put it all on this summary of results, I think this would be kind of a nice place to input that, and you don't have all these other side things to worry about. Okay. Now to Brandon's point earlier, and I thought to myself, oh, maybe we should put them there. If you wanted to, when you do your MD solids and you want to drop your screenshots right into this third sheet, go ahead and do it there rather than doing the document separately and then now having to go back. You could drop them right here and then reference back. Okay. All right, so that's practice problems. Any questions on practice problems? And those are the two that we just got through. So today we finished up that second practice problem. If for the first one you didn't do all of this business, then do the separate files if it's easier. I'm not going to worry about this, something that I kind of switch gears on you guys with. But for your assignment for module 6, which is assignment 6, oopsie, module. Assignment 6, I do want you to put those together in that format. Okay. So these I want you to, because I know you haven't started these yet. So please put that in that third tab and then submit the actual file, not screenshots. The problems that you're going to be doing are the ones that are listed here. 12.1, 12.2, 12.3. These are calculating gear forces. And when I talk about a sketch, I just want to see the sketch of where those tangential and radials are, okay, in relationship to the shaft. So if you look back at I'm going to reference page. You look back at page 513, right down here, this is what I'm asking for. Okay. So for instance, I want you to identify a direction of rotation unless it's given. I want you to show me where the point of engagement is between the two gears. And then depending on if it's a driver or a driven by the description that you're given, then I want to see the direction of the tangential and the radial forces as well as their magnitude. Okay. Now you can calculate the tangential and the radial, do a screenshot, and you can do that in our spreadsheet if you wanted to, okay, with the information they give you. Or it's not a hard calculation for either one of those. You can hand calculate those too. So totally up to you which way you want to do that. Okay. I say manual, you can use, somebody asked me and I said, sure. So they're there. And then the last two here, these are worth 20 points each. Doesn't seem like much compared to what you have to do, but they are worth more than the regular type of a problem. These are going to be full shaft design problems for you, numbers 22 and 28. Okay. And they're going to be found at the end of the chapter. Any questions at the moment? Okay. So as we, as we kind of look here then, I think we're done talking, if you would, about shaft design. Okay. So the rest of the time that we have together, I'm going to let you guys work. And then if I need to, I'll kind of come back up here and answer questions if it seems like it's going to benefit everybody. And we'll kind of see how far you guys get. The next time we get together, first thing I'm going to ask are what questions do you have on the shaft design assignment that you have? Okay. And I'll answer those and then we'll probably move into module 7 at some point the next time we're together. Okay. All right. So then I'm going to stop the recording.